more about that this morning. But not only has Richard not only has he been a pioneer in these areas, but he's also fostered and supervised amazing talent in this area through his PhD students. And without further ado, Richard, congratulations on receiving the Achievement Award from CHCCS. This is your plaque. Just a moment, everybody. We're having some technical difficulties. While we're waiting, maybe I can just explain about the program for today. We're going to have 3 technical paper sessions today. We're going to have 2 award talks, one from Richard and also one from our earlier career researchers. We'll also have our online poster session and a keynote from Sid Fells. As well, we're going to have the conference dinner that's happening later today at Bessot de Montréal. It's going to be awesome. I think it's going to be awesome, so hope to see everybody there.
Hello? Yeah. Great. Okay, thank you so much, Adrian. And thank you for the introduction, Sheldon. So I wasn't quite sure what kind of a word talk I'm supposed to be giving, so I decided to give more kind of a technical talk, and towards the end, I'll do my acknowledgement. So I decided to call my talk, Why is Computer Graphics Hard? So I hope it's not too controversial, and it's not too technical. It's mainly, high level. But let's first sort of set a background. So why would I even think about this question? So there must be some kind of a notion that computer graphics might be easy. So what is computer graphics? So I'm going to go to maybe the most authoritative text. It's sometimes referred to as the Computer Graphics Bible, and finally it has a new edition. So on page 2, this is the first definition of computer graphics. That is taking a model of objects in the scene, like what we see over here, and also light properties, and it's going to produce a rendering of the scene. And quickly, the authors call this process a glorified multiplication. Right? You're multiplying lights with your geometry. Now, in classical computer graphics, I'd say it's computer-assisted image synthesis, and the focus has been for a long time about efficiency and realism. So we should agree then that it's really a forward problem. You take an explicit scene description, your 3D geometry with light parameters, and then you're going to produce a rendered image. How about computer vision? So same book, I think the same page. The authors define computer vision as actually a factorization instead of a multiplication, where you kind of invert the process. And your input is a scene, is a rendered image already. And your goal is try to infer what were the geometry and also the lighting parameters, also the camera pose, and you try to say, for what sort of setup you would actually produce the input image. So in that sense, computer vision is an inverse problem. Your input is an image, and your output is the model description. So if you ask me, I'm a computer graphics researcher, but I have to acknowledge that factorization is harder than multiplication, and in general, inverse problem is more difficult than forward problem. But I want to emphasize this is the classical computer graphics. So in my mind, I think many people agree that we should be talking about what is the new graphics. Okay, so in my mind, we can keep doing synthesis, but I think the new graphics should be focusing on modeling, not just rendering. Specifically, the synthesis should not just be images, but all visual contents, especially 3D content, not just images. And we also need to change the input. The input shouldn't just be this explicit model description, explicit geometry. We can do a lot more. So I'm going to scrap this explicit model description. I'm going to say the description can be abstract. It can be highly incomplete, hard to acquire, even it's completely unknown. Okay, so here are some examples. So the input, you've seen works nowadays already. Actually, input could just be a piece of text. It could be a hand drawing, a single photograph, or the input is just a set of examples. I say, please look at these chairs, generate more chairs like those. Now I go back to one of the really early works just more than 10 years ago. So at the time, we didn't call it single view reconstruction. I think this is what the typical term in computer vision and graphics now. We call it photo-inspired 3D modeling. Really, it was doing exactly the same thing. So the input is a single photograph, and we're going to get a 3D model out of it. So clearly, this is a EU-posed problem. You don't have enough information to get your full and accurate 3D model, so you need some kind of a prior, some assumption. And the prior naturally can be just a data set of 3D shapes that you already have. So you take the set of data, 3D chairs, and then the approach we had was extremely simple, embarrassingly simple. So we're going to retrieve one of the chairs from the data set, and then I'm going to warp it just based on the silhouette. Well, of course, I have to align them in the right way. So that was the paper. It turned out to be a Seacroft paper, 2011. So one thing to note was that with this set of 3D shapes, you already have a lot of information you can actually embed into the data set. For example, you can have structure. Structure here means the parts. You also have relations, for example, symmetry and any other information. So when you do this warping, you can actually preserve those relationships. So roughly, so we take this input photograph, we retrieve a model, we align them, and then we warp it based on the silhouette. Of course, it looks okay from one view, but it's actually not connected even. And you have to restore connectivity and restore symmetry, and finally you can get a chair that looks about right from not only that view, but also from all views. So that was pretty much the paper. Now at the time, we did what I called a Google chair challenge. So we say we take Google search for the word chair, we get all the top returns. For each one of them, we try to reconstruct. Okay, so nowadays, if you look at a CVPR paper, CVPR paper, we call doing a single view reconstruction for images in the wild. It's considered to be more challenging than applying things to inputs that are similar to your training data. So I actually did a pretty good job. Now, let's fast track to 2021. So this was a CVPR paper. And this is, I think, is representative of the state-of-the-art neural network, so trained deep learning-based single view reconstruction applied to images in the wild. And if you compare them, actually these results are no better. I think they're actually worse compared to a paper that didn't do any machine learning and simply did retrieval. Okay. So really, I really think there's actually a lot to do. I actually feel, and I'm not going to talk about single view reconstruction, that a lot of the deep learning-based single view reconstruction may not be doing it right. And just to make a comparison. So I want to go back to this new graphics. So the new graphics to me is going to be data-driven, it's going to be example-driven, and you don't just synthesize, you actually first have to understand. Okay, so if your job is to generate, say, airplanes, you have to understand what airplanes are. So you have to analyze, and then you synthesize. So really much of it is really inverse problems, right? You need to actually understand, maybe from a set of examples, to invert the modeling procedure, and then after you obtain the generative model, you can apply the forwardly, even with kind of a random input, so GAN comes to mind, so that you can possibly generate novel content. So that is the new graphics. And indeed, if you go back to that graphics Bible, and there was a remark essentially saying something similar. So much of the current research in graphics is about creating geometric models, and at the end you see that there's an increasing integration with computer vision research. So we started by saying that the classical graphics might be easier than classical computer vision, and now we're catching up, right? So I say graphics is also doing inverse problem, but can we do more? Can graphics be more than just solving these inverse problems? So I want to go back to CGraph 2011 was held in Vancouver, and Jim Kajia, who proposed the rendering equation computer graphics, so many people know him, he won the Stephen Combs Award, and I was in the audience at his talk. It's a fascinating talk. So Jim started by asking this question. So if you think of all the computer science disciplines, there's data mining, there's numerical analysis, there's vision and AI and everything. So he was asking, what human capability does each CS discipline try to enhance or replace? Okay, there are some sort of obvious answers. For example, if you think of AI is trying to maybe enhance, maybe eventually replace human intelligence. Computer vision, the answer is pattern recognition. And of course, he's going to ask, what about computer graphics? Okay, so I want you to think about this a bit, give you 5-10 seconds, what would be your answer? So my answer was image creation, image synthesis, but I quickly discrete to myself because I think that's really not high enough of a goal, right? It's something that is kind of well understood from a physical standpoint. So Jim Kajia's answer was human imagination. Okay, so I learned it. I started to use this in my talk, but for a long time, I really actually couldn't find the original source. I wrote an email to Jim Kajia. Of course, I didn't get an answer. But actually, until this year, I actually finally found the source. There was actually a paper. Interesting, the paper was called The Convergence of Graphics and Vision. And then you see that there's a sentence there saying that, indeed, Jim Kajia mentioned that the goal of computer graphics should be about human imagination. If you think about it really, with computer graphics, you can create all kinds of special effects, and also we're now talking about AR, VR, MR, and computer graphics really is playing a central role in all of this development. It turns our imagination into digital content and virtual reality so that we can interact with it. We can even live in it. With all these buzzwords that we have today, metaverse or digital twins, whichever you want to call it, I truly think that computer graphics ought to be the main instigator of these developments. So that was 2011. Now let's fast track to 2022. You can see this is the era of AI, machine learning. Now there's another way, I would say, to think of what the new graphics is. And traditional graphics, again, takes this 3D scene, you can model and you just produce an image. Now with machine learning, people are starting to think maybe you can do graphics or you can generate these scenes in a different way using generative machine learning. This was a slide stolen from one of the CVPR tutorials. So now, for a while, I always think of the G in graphics as generative. So graphics is actually about learning to generate. And learning to generate is actually lies at the heart of artificial intelligence. Let me explain why I think that way. So when we think of AI, so one of the recurring questions is, when does a machine become human? So what really separates humans from machines, right? So people have been trying to find answers. So I want to see a show of hands. How many people know what the Turing test is? I guess most of you, right? So Turing test, so I'm not going to really explain it, is testing the machine's ability to make human-like conversations. And by and large, the test was considered to be passed around 2014 by a chatbot called Eugene Gutzman. So that can't be that easy, right? So, about 10 years ago, the was already passed. How many people know what is the Loveless test? Okay, I don't see a hand here. Okay, good. So Ada Lovelace is a very special lady. She predated Alan Turing about 100 years. And if you need a reason why girls should do computer science, this is the best example because Ada Lovelace is usually considered as the very first computer programmer in the world. And this, I think, is also Ada Lovelace Day. I think it's sometime in October. In any case, I think she worked on the first computer, and she had a quote which says that she actually didn't believe that computers could possibly be original or creative, okay? And then, so I think that quote was taken from her, and then the so-called Ada Lovelace test. Well, Loveless test is testing the machine's ability to be creative, to be original, to create something which is considered to be creative. So some people did believe that's a better AI detector than the Turing test. It certainly is going to be harder. So we tried to pass the Loveless test. We tried to have a machine that can create these logos. As you can see, they're quite creative, but we actually failed pretty badly. So it's certainly a very difficult problem. So overall, so this topic here I want to get to is called creative modeling. Okay, so there's actually a Wikipedia page which talks about computational creativity. There has been some attempts. So my colleague and myself, we have written a position paper about creative modeling, and to give you some hope, this is a quote. It says, "Creativity isn't a talent, it's a way of operating." Unfortunately, this was not a quote given from a Nobel laureate. This is given by a comedian. So if people know the movie A Fish Called Wanda. So computational creativity. So this field is, I think, is fascinating. It has three-tiered goals. The ultimate goal of computational creativity is to construct a program or a computer that is capable of human-level creativity. Okay, it might be too difficult. If that's too hard, let's try to understand mathematically what is creativity. That's still very difficult. So most of the works that we see today are those works that can create maybe a tool or a machine that in itself is not creative, but it can maybe enhance or help humans become more creative. So that was our attempt back in 2012. So it was about shape modeling. I'm a 3D modeling person. So instead of creating a single shape at a time, we'll try to imitate the process of evolution. So called the shape evolution. We start with a set of shapes and call that the first generation, and we're going to evolve it as a set. We call it a set evolution. And after 10 generations, there are shapes that are created from this initial population that look maybe creative, at least they're interesting, and they're highlighted by these orange boxes, and then this is after the 15th generation. So the evolution essentially works by producing offsprings imitating the two fundamental operators, which are mutation and crossover applicable to DNA codes. So our shapes, the shape DNA is just the shape structures. We take parts, and mutation is about deforming the parts, and the crossover is just exchanging parts. Okay, so that was our evolution for shapes. And of course, how do we get creative? So that comes from stochasticity. So there's some randomness to both the part mutation and also the part exchange, but you have to have control. Otherwise, you just get a lot of garbage, right? So in evolution, there's so-called a fitness function. You can think of it as a way to define what's good. And that fitness function now here is defined by humans. Human will look at, this is called a design gallery. Actually, this work was a really good combination between HCI and computer graphics, where the machine would generate a set of shapes, and the human would come in, looking at it as a design gallery, then it's going to pick, these are the ones I liked, and these ones I don't like. The ones I liked would be allowed to produce further offsprings, the ones that are not liked would just die. Okay, and I'm going to iterate this process. So there's stochasticity and also control. Okay, so that was a paper called Fit and Diverse, one of the first for, maybe you can call it a bit of a creative modeling for 3D shapes. And later on, we came up with another idea, which was inspired by the notion of co-creation. So here, the creative modeling is carried out using some collaboration. Okay, you can think of crowdsourcing, perhaps, at a larger scale. And the surprise element here comes from the fact that the creators, the collaborators, do not know everything that the others are doing. Okay, so there's some kind of element of surprise. So we applied that idea to a specific example. So this is called Exquisite Corpse game. I'm not sure if people know about it. So it's a game that you can actually play. You can try to create a poem or a storyline. And then here we look at an example of creating like a sketch. Okay, so this sketch is some kind of a creature that has 3 parts. The first person is going to draw the head, and the second person is going to see a little bit of the interface between the head and the torso, but doesn't see the entire head. He's going to draw the torso, and the last person is going to see a bit of a hint of the connection between the torso and the leg. Is just going to draw the leg without seeing the whole thing. Okay, so you can do this. You can actually try to come with a story, a poem, or adventure, or something in the same way. Because this work is basically about trying to apply that same idea to 3D modeling. Okay, modeling 3D shapes by playing exquisite corpse games. So not much technical detail I want to reveal here, but at the end we want to test whether doing this collaborative modeling actually increases creativity. And then here creativity is judged purely using a user study. Okay. Now, how about neural networks? I actually haven't seen many. Okay, some of them are doing so-called creativity modeling, but really it's about diversity. In fact, this perhaps one of the better-known works called Creativity Can is able to produce arts that are actually within distribution. Okay, it's simply trying to produce art that has a style which is different from known styles. However, one interesting observation is that when you try to come up with a compositional modeling, okay, this was from an ICCV a couple of years ago, that actually has the chance of possibly creative. What this means is that it does a better job of covering the out of distribution, which is not in your training set if you do compositional modeling, compared if you have a model which operates holistically over the shape. So I think there's actually a lot to do. It's a very difficult problem. So it's actually challenging to just create examples using a generative model that are out of distribution. But for creative modeling, I think it's even, that's not even enough. You actually need to consider things which are out of domain. So for example, I wanted to create these kind of logos, right? So not only do you have to have a kind of visual understanding of things, you also have to have the understanding of meaning. So what does kill or hide or disco or bird, right? So they actually have to come out of your visual domain and understand the meaning of this word. And then there are many other examples where creativity is kind of combining knowledge from multiple domains, and that's very difficult. And maybe creativity is personalized. And then finally, if you think of a data-driven or machine learning-based approach, it's very difficult to come up with a data set of creative outcomes, and how do you even set up a loss that is differentiable about creativity? It's a lot of open questions. So we can take kind of a step back, right? So let's just do data-driven or inspired modeling, where the data can provide examples for example-driven synthesis, and data can be a repository for retrieval, and certainly data can form the training set to train your GAN or your variational autoencoders. There has been a lot of success. Okay, so this was work actually done quite a few years ago. It's considered as an old paper by machine learning standard, the results for faces is amazing, especially from StyleGAN. Now, I always think that generating 3D shapes is more of a graphics problem. So this is considered the state-of-the-art results for 3D shape generation. As you can see, in terms of quality, they are actually far from satisfactory. There are indeed some unique challenges to 3D data. So this is one I want to get to. The first challenge is the 3D data challenge, that if you do a Google search for chair, you get millions of images returned. But if you do the same for 3D shapes, you probably get maybe close to 100,000. It's much smaller. So we still lack the big 3D data to train deep learning algorithms. The second challenge, I'd say, is I call affordance or functionality challenge. Okay, so why would you want to generate something in 3D, whether it's a 3D shape or it's a 3D environment? I think it's not enough just to look at it. You actually want to use it, because we humans live in a 3D world. The reason we want a 3D shape and 3D environment is actually interact with it, to live within it. So it's not enough for this thing to just look right from one angle. It's not enough to have the right parts. For example, CNN may say these are teapots, and on the right, these are faces if you do a max pooling at the end. But they're not faces. They're not teapots because they do not function. Right? So to me, the ultimate goal of understanding and also of generation, at least in 3D, is not appearance, it's actually functionality. They actually need to serve the intended purpose. So learning functionality is quite challenging. It's contextual, right? So functionality cannot be understood just by looking at a single shape. You actually need to see the usage scenarios. So from a data preparation perspective, you need to have the right data, right? And defining functionality in terms of descriptor is also difficult. You need to have interaction, you need to have contextual information. So recently there have been some attempts on trying to come up with data sets. So Manolis's talk probably will highlight more of these efforts. And functionality learning has been an emerging topic in graphics, in computer vision, machine learning, and also in robotics. So we try to actually combine functionality with this shape evolution and trying to generate shapes that are functional through this evolutionary process. So one key change here is that the fitness is going to be related to functionality to allow the tool to generate shapes that are functional. But the most fundamentally, to me, the challenge of 3D is representation. So unlike images or speech, there's not a single representation for 3D shape to say that's the right one. There are so many choices, right? So there's meshes, there's volume, there's point clouds. These are just low-level representations. If you go for higher-level representation, there's CSG, construct solid geometry, procedural models, scene graphs, and there's multi-view images. Right? So by the year 2018, most of these representations were mainly for discriminative analysis, and in terms of neural networks, they were focused mainly on voxel representations and also point clouds because of the success of PointNet. So I started to ask myself, what is a shape? Okay, so I've actually done this a couple of times. When I try to do something, I actually go to the dictionary. I see what is that, I try to go to really the fundamental definition. So shape, by definition, is an external form, is the outline of an area or a figure. So you say images have boundaries too, but image boundary is different from shape boundary. Image has a boundary because you have to crop it, so it's always rectangular. So shape boundary is what defines what the shape is. Now, you can define shape boundaries in different ways. You can define it explicitly by just drawing the boundaries. You can also define it implicitly by specifying what's inside, what's outside. This is inside, this is outside. So what's nice about this particular implicit representation is that the inside and outside are specified over this ambient field. And this ambient field actually shares much of the characteristics of an image or a volume. Now, shape representation or learning really shouldn't be about feature aggregation in these preset boxes. This is what CNN or convolutional neural networks does. Right? So you try to go through this different boxes. These are preset. These are convolutional kernels, and you try to extract the features. You try to summarize them. So I believe that this is suitable for texture inference. Okay, I'm not the only one to make that claim. There's actually a paper. The paper studied image classification, and essentially the message was that they found out that the CNNs tend to see textures because of the way it operates, but humans tend to see shapes. If you want the machine to recognize the one on the right to be a cat, you have to augment the data to say that's a cat, right? So there was a paper from iClear 2019. Now, if you take the implicit representation and to learn to generate shapes, you should be asking questions like this. At this point, inside or outside? That's outside, inside. You do many of these queries, and at the end, you're going to get your shape in an implicit way. And now to learn such a shape representation, you need to learn a function. This function takes a point P and a shape S, and it's going to ask, is the point P inside or outside of a shape? And you can say, 0 or 1, depending on your sign here. And this is the classical implicit representation. And we made a neural network that tried to learn such occupancy. Okay, so for example, after you've learned this implicit field, you can extract a shape by just taking a level set. So what's nice about this, first of all, I believe this is a good representation, and also a new representation for shapes, and also it can learn a continuous function. Okay, that is, if you can train your neural network on data with a lower resolution, 64 cube, you actually learn a function that can be sampled at a higher resolution. So the network was actually extremely simple. So it just takes a code that was encoded by some encoder, and then take a coordinate XYZ and goes through several layers of MLPs, and at the end it's going to produce a number, which is called occupancy, whether it's inside or outside, and this can be trained using point value pairs. So this was called IMNet CVPAIR 2019. And to compare this with the classical CNN-based shape generation, you can see a clear contrast. So here we try to see how the network learns to adapt to learn these letter A written on white background. So on the top, you see how CNN adapts. So it actually adjusts the image intensities and eventually gets to an A. And for the IMNet implicit decoder, it quickly gets the overall shape of an A and does a shape boundary refinement. And then if you do what is a typical test called interpolation, again, I'm going to sort of ignore the technical details, you just see the outcome. So CNN does the interpolation from one A to the other A by doing the image intensity adjustment, right? But IMNet does it the right way. It actually moves the A, right? So there's a clear contrast. So since CVPAIR 2019, amazingly, 3 papers basically came to exactly the same idea. These are called IMNet, DeepSDF, and OCCNet. And it kind of started a mini revolution on neural shape representation. These are neural implicits. Learn continuous functions leading to the best quality to date. And there have been many follow-ups. I'll go through these things fairly quickly. I don't want to run out of time. So one line of extension or generalization is to go for a structured implicit representation. You have parts and relations. Another line of approach is to actually get a mesh directly without using marching cubes. This was our work called a BSPNet. Actually took a very classical graphics concept called binary space partitioning. And this paper was the winner of the CVPAIR 2020 Best Student Paper. And grasping, okay, hand grasping is also a really good application where you can use implicits because it's really about context and interactions. And this paper is not our paper, actually was the winner of the 3DV 2020 Best Paper. So a lot of follow-ups. And finally, by now everyone knows NERF, right? So I agree with Frank Dallard that you can think of these 3 papers on neural implicits as a precursor to NERF. Okay, so they both use NLPs, right? Just dimensionality of the inputs and outputs are different. So for more detail, you can go to this coverage by Frank Dallard. Okay, I'm almost concluding. So why is computer graphics hard? I believe the graphics is hard because it's not responsible for many new things. It's certainly responsible for addressing the 3D data challenge from acquisition, modeling, understanding, and interaction. I think graphics is responsible for producing big 3D data. We're still not there yet. So again, I'm pretty sure that Monolith would be talking about this topic. And graphics is hard because it's not just solving forward problems. There are so many inverse problems that graphics is responsible for solving. Training machines, neural networks for generative shape modeling. And finally, this is a hard one. I believe graphics should be responsible for realizing and enhancing human imagination and creativity. And on many fronts, we're just scratching the surface. So graphics is really hard. You should be doing graphics. Okay. Now, this is the part where I want to thank, first of all, I want to acknowledge the main students and collaborators that actually worked on the papers that I've covered. And my students, these are my current students and postdocs, which will be working with me, continuing on this journey. And these are all the students I've supervised. Some of them are in academia, some are working in companies. I try to thank my collaborator, but the list is too long, so I just resort to Google Scholar. These are my collaborators listed by Google Scholar. My future collaborators, you can get some hint from this tweet. Okay, so there are many Richard Zhangs doing visual computing and AI. So this Richard Zhang is from Adobe, and he wrote a tweet. He actually added several Richard Zhangs. And then someone said, you guys should be writing a paper together. Zhang and Zhang, Zhang and Zhang. And I made a comment, actually my Chinese name, Hao Zhang, even has more of a mode collapse because there are even more Hao Zhangs doing similar works. So it'll be fun. I want to thank my two most important mentors. My supervisor, Eugene Fiume, University of Toronto. That was a picture where they had a lot of hair. And amazingly, after many years, I was able to get Eugene to come to the same university. So Eugene is actually working at SFU right now. My other mentor, Daniel Cohen-Orr, who is my nominator for this award. And I couldn't really find good photos with Danny, so I found this one. I'm actually curious how this guy is doing. This one was from 2011. And now, with machine learning, of course, I have to show what machine learning made us, Danny and myself, look like now in style. So if you're interested, check out this paper, really, really fun. I also want to say that SFU has grown tremendously over the past 5 years in both computer graphics and HCI. So we're a very strong graphics group and also equally strong HCI group. And I was making this slide, I was amazed to recall 5 years ago, this was the picture. I was the only person at SFU. And now I'm taking a leave for 1 year, working full-time at Amazon. So Amazon is not like a best-known player working in 3D graphics. You think of NVIDIA, you can maybe Google. So this was a job ad I posted recently. So we're hiring. Okay, it looks like we found our right person. So I wanted you to note this sentence here. So our team has this goal, which is to create a 3D model for everything Amazon sells online. This was the exact sentence that drew me to Amazon. So a lot of challenges, 3D modeling, reconstruction, these are 3D graphics. And Amazon actually has a new program, Amazon Postdocs. So that's it, thank you very much. I'm gonna leave it with a little video. So this was an interview question, what was the most innovative paper? It's actually this paper we did in SIGGRAPH 2016 using Fermat spirals for two-path planning. This is, if you're a 3D printing person, you know what this is about. Try to find a space filling curve that fills the space in a continuous way. And then I just thought it's beautiful. And it uses this spiral, but very few people know it's actually due to Pierre Fermat, the one has the Fermat-Last theorem attached to him, but very few people knew he actually developed a spiral as well. Okay, I'll let you to look at it, mesmerize. I'll be happy to answer any questions. Thank you very much.
Thank you, Richard, for that very inspiring and amazing talk. Do we have any questions for Richard from the audience or on the Discord? I don't know if there are Discord questions. Oh, there's one question in the back.
Thanks for the great talk. At some point you mentioned creativity and functionality as two kind of goals. And I guess one could see them as like contradictory, right? And it's not necessarily that the most beautiful creative thing is useful and vice versa. So how do you kind of reconcile those two objectives?
I think that's an excellent question. If you notice that when we did this user study on this exquisite corpse game, we actually contrasted functionality and creativity. So indeed, if it's more creative, it's less functional, right? By the end, we tested that the compositional modeling using exquisite corpse game actually did a bit better if you consider both factors. I believe that functionality is more fundamental, right? So you have to first get functionality, and then you can go for creativity, not the other way around, right? So, I mean, you often have these kind of trade-offs, right? So, so that's an excellent question. So, how do we do it? We don't even know. We don't even have a deep neural network that's able to generate things which are fully functional, let alone creativity. So we have a very, very far way to go.
Thank you.
I have a follow-up question to that. I found it really interesting the points you were raising about creativity and whether or not machines can be creative, and proposing the Loveless test. I'd never heard of this, but this is really interesting way to formulate the problem. And so I was thinking about this, the infinite monkey theorem. And,
sorry, I missed
the
it.
infinite monkey theorem, where I guess the graphics equivalent is like you could have 1,000 monkeys at 1,000 copies of like Blender, and eventually one of them would sculpt, Michelangelo's David. And we would all agree that like Michelangelo's David is creative and it's artistic and interesting, but there was no intent. So do you think creativity is linked to intent? Like you have to demonstrate intent to also demonstrate creativity?
So you could create something which is sort of creative out of 1 million tries, right? So so by the way, I have to acknowledge I'm not an expert on creativity. There are books written that encourage you to read about how do you define creativity. But as a computer scientist, I wouldn't do it that way. I would do it in maybe a more intelligent way, not just you happen to get something which is creative. You actually need to have an intent, right? So for example, you can call it you need to have some kind of inductive bias that you can actually put in if you have a machine that is considered to be creative. So indeed, I think that's why there's more challenge. It's not just about getting one out of so many that could be considered as creative, but you actually have to design something which has some kind of assurance of success. I'm not sure if that answers your question.
Yeah, absolutely. Thanks. Thank you. Are there other questions for Richard? If not, I'm going to suggest you catch Richard during the coffee break and ask him if you have any questions or want to discuss with him further about these amazing things he's worked on. And I just want to thank Richard one more time for this talk and congratulate you once again on receiving the award.
Thank you very much.
So next up we have an invited speaker, Jian Zhao, who is going to present, and I'm going to hand it off to Fatima.
Okay, it's my pleasure to introduce Dr. Jian Zhao, who is an assistant prof in Sheridan School of Computer Science, University of Waterloo, where he directs the WhatWiz Waterloo Visualization Research Group. Congratulations on that name, actually, I love that. He's also a member of the Waterloo Artificial Intelligence Institute. His research relies in the intersection of information visualization, human-computer interaction, and data science. He is dedicated to developing interactive visualizations that optimizes the analytical workflow of solving complex real-world data problems. He received his PhD from Department of Computer Science, University of Toronto, and he is a recipient of 6 Best Paper and Honorable Mention Paper Awards in top-tier venues. He also served on program committees of many world-class conferences, Viz, Chi, and taken leadership roles in these conferences. In addition, he has experience working at other leading industry labs, including Microsoft, IBM, Adobe, and he holds more than a dozen patents, and some have successfully generated impact on products. So forgive me for reading from the text, because it was a very long list of success. Congratulations. And without further ado, I invite Dr. Zhao to start his talk. The floor is yours.
Thank you. Thanks for the introduction, and it's very honored to be here. This is actually my first in-person conference since the pandemic, so I feel super excited. And today, I'm very happy to share some of my work on designing intelligent visual information seeking interfaces. So let's talk about data, right? Data is the raw information we have. We know they are there, and it's scattered everywhere, and we cannot make use of them. In order to make use of information, this raw information, we need to leverage machines. So machines, we can do modeling, computation, derive insights and knowledge. But this is not enough. As a researcher in HCI, I think we should put human in the loop. So human has this creativity, as that's actually reflected on Richard's talk. Human has creativity, imagination, and I really think we need to put human in the loop and make those 3 things work together to generate insights. So let's talk about the big question. How do we design better information-seeking interfaces? So I think our strategy should be threefold. So first, we need to design for data. We need to respect the characteristics of data. We need to use data-driven designs. And secondly, we need to design for machines. We want to develop interpretable machine learning models and leverage machine to do the right tasks, but not all the tasks. Thirdly, we need to design for human, design for users, make user-friendly interfaces, and leverage their domain knowledge and creativity. And I really think data visualization is the glue here. So data viz can facilitate the interplay between data, machines, and humans. And let me show you something more, a little bit more concrete. So suppose that you want to design for the next generation of visual information seeking interfaces. And this big hollow circle represents all the information you have, possibly, maybe have a boundary or not. And the right dot here is your target. Sometimes this target is unknown and very vague. And the yellow dot here is where you are right now. That is your query. And based on the current limitation of the machine learning models or whatever analytical models, the green solid circle actually represents the results that you can currently query, currently get from your input. And I think the first thing what we need to do for effective visual information seeking interfaces is to interpret the search results. So we need to display and present the search result very well so human can understand, can think about, okay, is that what I want? Do I need more or less? So the second, I think we need to leverage machines. We need to make the human to guide the search execution. So that's the machine part. We need the machine model to be interpretable so human can guide the models towards a target. And thirdly, I think we need to design the system to support serendipity. So that's the human part. Along the way of from a query to the target, you might want to find some unexpected findings and get some extra knowledge, and you can use in the future. So in the rest of my talk, I'm going to quickly go through some of my past projects and experiences in designing effective visual information seeking interfaces for different domains. And because of time limitation, I cannot go into too much technical details. You can always check my website for the details. Okay, so this is the big picture. The first case I want to talk about is the regarding exploratory programming using Jupyter Notebooks. That's a very popular tool in data science. And one task we have is seeking code, find the right example codes in notebook corpus. For example, you have a lot of notebooks and you just want to solve a problem, solve a task, and you want to find the right piece of code in Jupyter Notebooks. Compared to traditional software code search, this Jupyter Notebooks code have some challenges. The first one is it has this kind of nonlinear structure because the code can be executed in any arbitrary order and it's on the fly. And second, the code is divided into code cells, and those code cells have very complicated relationships, dependencies, and so on. And thirdly, you may not want the entire Jupyter Notebook. Sometimes you just want the piece of code that is useful for your task, for your question. And there's not enough semantic information to support natural language-based search, such as comments, docstrings, and so on. People are lazy. People don't put a lot of docstring and comments in Jupyter Notebooks. And you don't know the exact API to search, so sometimes you want this kind of natural language-based semantic search. It is hard. So to address that question, those questions, the challenges, we designed a tool called NB Search. It is a visual search interface for finding useful code in large notebook corpus. So let me show you a quick demo about that. So the user could enter, like, say, KN to perform classification, and a search bar, and then a list of code cells will be shown on the left, and each color is mapped to a different notebooks. There's also visualization in the middle, shows the search results. Each line corresponds to a notebook, and each dot corresponds to a cell in that notebook. And if you click one cell, the entire notebook will show on the right. And there's also black curves in the middle, shows the relationship between different code cells. And by exploring the results on the right, there's also tags emphasizing the important functions and variables in the notebooks. And there are also the green bars shows the similarity between that code to your query. So based on those visualization and this interactive interfaces, it helps user to identify the useful code from their search and explore the inter and intra relationship between those searched code cells. So I know that there's a lot of to show and in a couple of minutes, but what I want to emphasize here is this interactive visualization that help users interpret the search results. So the search results is a bunch of code cells. They are organized vertically in a line, and that line represents that Jupyter notebooks the cells are from. And horizontally, it also aligned based on their similarity. And these lines and dots and the black curves help you to review the inter and intra notebook relationship. So this is where I want to emphasize is like you need to interpret the search results very well using interactive visualization so human can make sense. So under the hood, the search engine we built has a complicated pipeline, and it mainly contains two modules. The first is a translation module, where it can generate any code, it can generate text descriptors for any code cells in the corpus. So you have a natural language description for every code. And then another module is this language models that can help user to find the right code by comparing the query and the text descriptors of the code cells in natural language. All right, so that's the first case. The second example I want to show is about exploratory visual analysis. So what is exploratory visual analysis? It's basically you have a data and then you want to find something interesting in it. And you generate charts along the way. That's exploratory visual analysis. So what are the challenges? So first, you can see that where I'm going, this visual exploratory analysis process is actually a search for visualization, a search for charts along the way, right? And you have two challenges. The first one is you lack a big holistic picture about where you are right now and what the charts you have created. What is the entire visual information analysis space? That is the what is now question. The second is what's next question. So because creating visualizations is regarding mapping the data variables to the visual variables, there are actually tons of different options you can make. So what are the data you want to explore in these spreadsheets or data tables, and what charts do you want to use? So it's very difficult to decide. So to facilitate those two challenges, we developed a tool called Chartseer that can provide a visual summary of the charts that you explored in the past on this data, and also offer recommendations of charts. Again, let me show you a quick demo. So you can see in the middle there's a canvas, and each glyph, circular glyph here, is a chart. You can hover over on it to examine the charts. In this case, it's a bar chart. And you can click it and add it on the left panel. And this visualization of charts is, I'd like to pause here a little bit. So this visualization of charts, it represents your analysis space, and the distance between those glyphs, those charts, is mapped to their similarity. So you can see clusters and gaps and so on. So the user can click any empty location on the canvas, and it will retrieve recommendations on the right. And the user can browse the recommendation. If not satisfied, can click again to retrieve more recommendations in that local area. So the user is giving guidance to this recommendation engine. And if the user want to like a certain recommendation, can make modifies, edits, and then add that to this canvas, update the entire analysis space. So again, this is a very complicated tool. What I want to emphasize here is this human-guided kind of chart recommendation. So it allows you to guide the search execution because you click somewhere and then it just recommends the charts in that local region in the analysis space. So the whole recommendation process actually contains several complicated steps. So in a nutshell, you click somewhere, we do a sampling in that local area and project those 2D points to a high-dimensional latent space, and then convert that latent vector to visualization. So in order to implement this, in a nutshell, under the hood is actually we trained a encoder-decoder architecture to convert charts to and from visualization. And use those two processes, we can do chart summarization and chart recommendation. The specific model we use in this work is GVAE, it's a Grammar Variation Autoencoder. Okay, and the third case I want to share today is about data gathering and wrangling. So you probably have already guessed what I'm going to search, right? We're going to search data, which is the raw form information we have. So we know information is scattered everywhere, as I mentioned in the beginning. And it's difficult to put all those information together in a format that you can apply all kinds of tools. It's just like you want to train a machine learning model, you need very clean data and labels. And if you want to do some visualization, you want them to in rows and columns. But a lot of the case, the data is not in a table. And even you find some kind of table that you can manipulate, it is difficult to extend this table with more rows and more columns to get the data set that you use, right? So in this work, we are trying to address the challenge of searching data to create ad hoc tables. So the tool we developed is called Tabulator, which can help users to grab scattered information on Wikipedia pages to form a structured ad hoc tables for further analysis. So suppose that you work in the film industry, you want to do some analysis on movies. And the user can start by just searching on Wikipedia, like Dark Knight, and then copy-paste the URL to the Tabulator. And with this, the system suggests different properties of rows that they can add. For example, the user can search director and to add all the movies that directed by Chris Nolan, right? And then the system asks you whether you want to form the first column with all the movies directed by Nolan, and then you can further add other properties to this table. And you can extend this this table by adding more columns. For example, I want to add some other movies, such as thriller movies and IMAX movies for other. So by just simply type the search properties here. So basically, you're extending your table by adding more rows, the first columns. And you can also do filtering. I wouldn't talk more about that. And second feature I want to introduce here is extend them with more columns. So you can click the edit button, maybe you didn't see that, and then it will suggest different properties to add, such as distributor and starring, whatever. And you can click any attributes that you want to add, for example, starring here. And this, because each movie has multiple stars, actors, and you can put them in the same cell or separate columns. So I think you get the idea. So basically, this tool allows the user to extend this table by adding more rows and more columns by comparing the schema of the table and also based on the knowledge graph representation of the Wikipedia pages. So this always on the fly suggestion of the rows and columns is a key. So it encourages the user to discover more data, maybe something not related to what they find, but this serendipity allows them to explore the table and discover more insights that can be used in the future. So, in summary, I have presented a few cases on designing visual information seeking interfaces, and each of them focusing on different type of targets, including searching for code and searching charts, and lastly, searching data. So through all the examples, I also demonstrate some important design considerations to make this interface more effective. So the first is we need to consider from the data perspective, we want to interpret the search result very well so the user can understand the data and make wise judgments. And secondly, we need to design from the machine perspective, where we want the human want to work with the machine in this kind of human AI interaction kind of scheme to allow them work together and towards that goal. Right? And thirdly, I argue from the human perspective, we want to encourage the creativity. We also want to enhance the serendipity discovery and allow the users to search for, go to the target, but along the way pick up some other actual knowledge and expected findings through visualization and interaction. So with that, I'd like to acknowledge my co-authors and collaborators who worked on the paper that I cover in this talk, and take any questions. Thank you.
Thank you very much, Dr. Zhao. And if anybody has a question, please raise your hand or post it on Discord. While we are getting people to think about their question, I have a question. So you mentioned that you want to think about having human in the loop when they are looking at their data visualization. I wanted to get your input on how do you think we can make visualization more personalized, or give them tools to make it customizable for their needs? And what are the challenges in that?
That's a very interesting question. So get visualization personalized, I think there are many aspects. The first aspects, like I said, is very similar to the tool I showed in the talk, the chart here. So the visualization is recommended based on where the user click on the canvas. The canvas represents the entire analysis space. And if the user wants some visualization here, you get some visualization here. If you want some visualization over there, you get visualization over there, right? But another aspect I would say is on the visual part, right? How can you generate the suitable colors and suitable representations of data? And that is another very challenging problem. So I think, yeah, so allow human and AI to work together. They should, you should provide interfaces allow the user to input, right? A lot of the, some interfaces can be very simple, like more like this, less like this. Some of the interaction might be more implicit or explicit. So there are different spectrum for interaction we can investigate to make visualization more personalized.
Thank you very much. I guess we have a question. Please go ahead.
Thank you very much for the talk. Maybe this is related to your last question, to your last answer, but I noticed that you framed your research mostly in terms of search, which sort of, to me, suggests that the sort of space of possible answers exists, and we're looking for it, and we're going to try and find it, and the machine's going to help us. I guess I was kind of curious about how you feel that contrasts with the notion of construction, like that the answer doesn't exist and we have to construct it, and the machine can help us build a visualization, as opposed to it's already out there and we have to find it. Like, is there something to think about there?
Yeah, I think that's a very interesting perspective. So in terms of search, is like you said, it's like it's already there and it's just haven't found it. It may be composed by different complicated parameters. And from construction, you can only build the things possibly can allow you to build, right? So you have those Lego pieces, although you can build a lot of stuff and new things, but you kind of limited by the sources and materials that you have. So in a sense, I think search and construction, they they are quite related to each other. It's just different thinking perspective. But I really like your perspective on that. And also I think maybe we can allow the user to discover new materials through system. For example, you build visualizations for the data, and sometimes you find maybe I missed this specific thing. I want it to be added to my toolbox. And then for the future, I can reuse them and build new things. It's like just like if you think about human history, we build a lot of tools. In the beginning, we have bones and stones. We use those for tools, and then we build tools for building tools, right? I think in computer science, we sort of like follow the similar path. But I'm not an expert in human history. I just want to make an analogy on that. Since we are building tools to build more tools, and it become more complete. But is there a boundary? Is there a space that we have all possible things? I think that's a very interesting question. I don't know the answer.
I just want to follow up on that as well. I think it becomes very complex when you want to give a lot of choices to the user to construct their own visualization. But at the same time, you don't want to overload them because they're not necessarily data expert or visualization expert. So this is the challenge I face. I don't know if you have any input on that.
Yeah, definitely. So if you reflect on the system that I showed today, although the interfaces may look a little bit complicated, but the interaction is actually simple. For example, chart here, you just click, and then you get a recommendation. You can refine on that if you don't like the recommendation. And the Tabulator, basically just two buttons, one extending rows, one extending columns, and you get all those kind of recommendations on the side. And for the first example, it's a search bar essentially, but and you can explore the data with visualization. So I think the UI and the interface of this can be designed simplistic, but the underlying models and analytics can be complicated. There's a trade-off. So I think I support more simple UI. Don't put extra stuff if you don't need it on the interface, and try to implicit guess what the user wants in the visualization.
Thank you. That's a very tough job. Yeah, go ahead. Oh, there is a question. Oh,
okay.
Sorry, I have too many questions for you. So, repeatedly generating data sets or visualization until something interesting happens seems like a dangerous setup in light of confirmation bias selecting results that match a pre-selected hypothesis and p-hacking. Repeating measurement experiments until something interesting happens by chance. What sort of strategies might this kind of search interface build into to help people avoid these pitfalls?
Okay, this is a long and profound question, so I don't have a lot of time. I will just briefly input my comments on that. I think the last point I talked about today in discover serendipity is essential for this. You want to always to recommend something that seems irrelevant but may be useful. You cannot, when you're building the search interfaces, you don't want to always show the user want. Sometimes you want to add some novelty and diversity along the process. I think serendipity is really important for building the search interfaces. We need to consider the three different things at the same time and equally. Data is important, machine is important, human is also important. So once you have those other three aspects, you want them to glue together and work together, possibly you can address this issue. Yeah. Thank you.
Thank you very much. There is another question. No?
Oh, okay.
Hi, thanks so much for the really interesting talk. And you answered a little bit of my question already with what you just said. I was just going to comment that the designing for discovering serendipity I thought was really a poignant thing to bring up. And I was wondering if there are design principles that you've used to kind of guide your design to meet that goal. And you kind of talked about it a little bit there, but perhaps you could expand upon it more.
That's a very great question. So what are the design principles for serendipity? I think this is not a new topic in database research, but as far as I know, I don't think there's some kind of design guidelines and principles for serendipity specific, but there are design guidelines for general like human AI interaction design guidelines. There are papers on that. Maybe this is an opportunity to write a paper, on like how you create, how you can inject this serendipity and new things into the human AI process. Sorry, I don't have an answer for that, but yeah, I think that's a really interesting topic to talk more. Yeah.
Thank you very much. Please join me in thanking Dr. Zhao one more time.
Thank you.
So now we have a coffee break for 30 minutes, and we will be back here for the next session. Thank you.
Okay, good morning, everybody. Thanks for joining this last morning session. The session is called Up Close and Personal, and we have very exciting talks. The first talk is by Stan Novak. The title is I'm Not Sure Designing for Ambiguity in Visual Analytics. If you can play the video, please.
Hi, I'm Stan Novak, and I'm a PhD student at Simon Fraser University. Today I'll be presenting research on behalf of my supervisor Lynn Bartram and myself on designing for ambiguity in visual analytics. So what do I mean by ambiguity? When trying to make sense of the world, we often find ourselves looking at alternative perspectives. This is a natural and often advantageous way to make sense of a world that is not always how it appears. Let me give you an example of what I mean. Imagine that you and a group of friends are planning a trip or vacation. You start looking online for reviews and top 10 lists of potential places to go. And while looking through them, you keep thinking to yourself about whether these are genuine reviews or the result of paid advertising, bots, or are otherwise fake. You might have a friend who is a really avid hiker and is really fit, and they suggest what they call an easy hike. But you know that what easy means might be different for every person in your group. You have to take all of this information and collaborate with your friends to identify potential destinations, think about the potential outcomes, and ensure that you all have a good trip that addresses all your needs and interests. Ambiguity is a consequence of complex systems. Everyday life is a complex system. The information we have available to us is flawed and incomplete, and we have to figure out ways to explain it, interrogating it from multiple perspectives to understand what it means and what the implications might be. When planning a trip with friends, having a bad planning process could result in a bad or boring experience, but in other situations, the consequences can be much more dire. One such complex system is public avalanche forecasting, where forecasters predict snow avalanches and communicate the associated risks to the public. Avalanches are destructive natural disaster phenomena that endanger human life and infrastructure. Through a series of qualitative, observational, and interview studies, we came to understand that ambiguity plays a significant role in several levels of sense-making. Ambiguity arises from data. One primary data source used is human-reported field observations of avalanche occurrences and snowpack conditions. With these human-generated reports, context matters, and the forecasters have to understand the who, what, where, and why to really understand how to make sense of the data. The second are remote weather stations that are very sparsely distributed and subject to a variety of errors, requiring interrogation from multiple perspectives. Forecasters work in a remote office environment where they collaborate on analysis both synchronously and asynchronously. Each individual forecaster holds a unique perspective based on their own knowledge and experience, which they use in the analysis of data. This presents a set of alternative perspectives that have to be considered. With limited time and multiple potential analytic paths through the data, forecasters must plan and manage their analysis carefully and often reconcile inconsistent findings. Finally, the forecaster's assessments have to be communicated to a public audience who vary in their level of expertise and comprehension. To maintain clarity and address this broad audience, forecasters have to simplify their findings. Whenever complex analyses are shared, context is lost and information can be interpreted in a variety of ways. In a close and ongoing collaboration with avalanche forecasters, we've designed several visualizations addressing the core data sources used in their work. We found how visualization designs can enhance or impede their sense-making processes. Weather station data, often referred to as weather observations, are traditionally viewed through a geospatial view that serves as a portal to external resources where individual stations' telemetry are viewed in a text table format. This creates significant overhead for the avalanche forecasters. To deal with this fragmented workflow, we used a conventional visualization design approach, relying on numerical aggregations to provide an overview of patterns and summaries in the data, and interactions to allow forecasters to drill down on subsets of data that might be of interest. The visualization tool was used for one operational season, and we found that forecasters kept returning to raw data tables. While there's always some form of path dependency or a need to use familiar tools, through interviews with the forecasters, we found out there was much more going on. They told us they had issues trusting the visualizations because weather stations are subject to a variety of errors, and they've developed strategies for scanning tables for clues for what might be going on. These errors might be due to environmental factors that cause sensor failure, or they might be more systematic biases like weather stations being located at particularly windy locations that have to be mentally adjusted or corrected. Numerical aggregations hide these critical contextual details and impede the ability of forecasters to sense-make around them and adopt the appropriate interpretation. Our experience designing the weather station's visualization taught us that conventional design approaches might not be appropriate in this context, and we took this lesson to heart when designing visualizations for avalanche observations. These data are also viewed through text tables and are also context-sensitive despite being well-structured. When designing these visualizations, we chose to break with tradition. We chose a packed bubble chart glyph design embedded in a variety of spatial and visualization contexts. Individual circles correspond to individual avalanche observations, and their visual properties correspond to attributes of the avalanches, such as avalanche size, the number of avalanches observed, and the types of avalanches. Typically, visualization guidelines value strong visual encodings, where strong means precise extraction of values and where patterns and data pop out at the user and draw attention. In a sense, visualization designers have to decide for the user what is relevant to consider and which patterns to amplify. Also, visualizations often use numerical aggregations to summarize data and provide an overview. By contrast, our glyph-based design used relatively weak visual encodings and no numerical aggregations. The patterns in data have to be found visually and deliberately, and the perceptual salience or visual importance of any given element is lessened so that there is no strong visual hierarchy. In addition, we chose to show individual reports, the most granular form of data, to allow the forecasters to look at contextual details and clues that might signal to them what the interpretation that is appropriate for the given report might be. Throughout the design process, forecasters informed us that they were worried that numerical aggregations or overly precise displays of data might lead the reader or forecaster into a false sense of precision, where they are lulled into complacency and fail to scrutinize the data and adopt the appropriate interpretation. We acknowledge throughout this process and in our designs that analysis is not purely data-driven, that knowledge and experience are the basis for interpreting data and looking at it from different lenses. To better support this way of thinking, we use what's called desirable difficulty. This is the idea that introducing visual difficulties or additional effort to a task, such as reading a visualization, can lead the reader to spend more time with the information and more carefully consider it. When dealing with complex situations or data like avalanche forecasting, this can have beneficial outcomes for analysis. The key takeaway from our research is that ambiguity needs to be designed for and not away. As technologists and designers, we often feel the need to reduce or remove ambiguities, but this can be difficult in complex situations, where what is relevant is context-sensitive and situationally contingent. In this research, we used visual difficulties, which we found can provoke more careful sense-making around such complex situations and data. And when creating visualizations for ambiguity, we suggest designers consider flattening the visual hierarchy so that no individual element stands out, allowing the user to choose what to focus on and to support varying interpretations. In addition, we suggest showing the appropriate level of data granularity, where contextual details relevant to analysis can be revealed. And finally, giving easy access to raw data is important because any form of data transformation can hide these critical contextual details. While this research has focused primarily on the visualization of existing data, we feel there are other methods that can better address ambiguities arising at the analytic process and collaboration levels. In future work, we want to explore capturing ambiguities in interpretive processes more explicitly during the process of analysis. I want to take a moment to thank our supporters and open the floor to any questions. Thank you.
Thank you, Stan. I think there is a question.
Thanks very much. Great presentation. My question is around the use of the word ambiguity as opposed to uncertainty, which sort of also gets used in similar work, and I'm curious if there's a distinction you're drawing between the two.
Yeah, that's definitely really deliberate. In the Viz community, the word uncertainty has certain connotations, usually around data uncertainty. And I think this is more of a problem of interpretation. Ambiguity operates at the level of data interpretation. There's knowledge-based processes involved. And generally, that involves generating and selecting and evaluating from between alternative ways of framing and explaining a problem. And so the use of the word ambiguity is really to differentiate it from data uncertainty and kind of statistical uncertainties, numerical, yeah, those types of things.
I have one question. So how do you think this will be generalizable to other use cases to design for and not away from ambiguity?
Yeah, well, I think there's a lot of similar situations. I think when you have risk-based analyses where there's, for example, low probability but high consequence situations where you're dealing with data that's been generated from a number of different, through a number of different processes. If you think of the COVID pandemic, different jurisdictions have different ways of reporting data and generating it, and you have to kind of factor that in when you're comparing or doing certain analytic tasks. So there's quite a few domains that are similar to this, but ambiguity is really a part of general sense making. We're constantly thinking and trying to explain the world and weighing different theories or interpretations of the world. So it is quite a generic way of thinking. So I think in that way it generalizes as well.
Thank you, that makes sense. Okay, if there's no more question, we can please thank Stan.
Hello everyone, my name is Purna Talkad Sukumar and I'm presenting our paper titled Triggers and Barriers to Insight Generation in Personal Visualizations. So what is personal informatics? Lee et al. Defined personal informatics systems as those that help people collect personally relevant information for the purpose of self-reflection and gaining self-knowledge. Personal informatics research has especially been inspired by the quantified self movement, whose goal is to empower people to gather and reflect on personally relevant information through low-cost sensors and wearables. Lee et al. Define personal informatics systems as consisting of 5 stages, namely preparation, collection, integration, reflection, and action. And we are interested in the reflection stage. And it is in this stage where people self-reflect on their personal data, and this is mainly achieved by exploring and interacting with information visualizations. Hence, there is a specialized field of personal visualizations that has emerged within the InfoVis domain and that focuses specifically on interactive visualizations of personal data. Common examples of personal visualizations include those presented by the apps associated with wearables such as Apple Watch or Fitbit. Personal visualizations have distinctive goals and usage characteristics. They aim to support self-reflection. They are consumed in less formal contexts and often on mobile devices. And people have varying motivations, interests, and resources for interacting with their personal data. And these distinct characteristics give rise to a number of challenges for designing and evaluating personal visualizations. Some challenges in designing personal visualizations are defining appropriate baselines for comparison, sharing and privacy concerns, including target users in the design process, defining context to facilitate recall of information, and including automatic analysis of data. And challenges in evaluating personal visualizations include studying users interacting with their own data, conducting studies in realistic settings as opposed to controlled lab studies, and using meaningful methods as well as meaningful metrics, such as ease of use and insight as opposed to time and accuracy. And to study personal visualizations, we designed an interface presenting the personal data gathered during the Tesserae study. The Tesserae study was a large-scale multi-university research study where data was collected from 557 information workers across 5 organizations or cohorts for a period of 1 year. And various health and activity metrics, including sleep, steps, heart rate, and physical activity, were gathered using a Garmin VivoSmart 3 wearable. And proximity information from gimbal Bluetooth beacons were captured to determine the number of hours a participant spent at their home or in their workspace. And we built a web-based interface presenting visualizations of the personal data gathered in the Tesserae study. And this is a screen capture of our interface. And for each participant, we generated a unique anonymized link which populated the data corresponding to the participant on the interface. And for each participant, we present 6 types of features, and these features include activity, sleep, heart rate variability, number of hours spent at home, and number of hours spent at the office, as well as steps. And we also present 2 types of summaries for each feature, namely weekly and monthly summaries. We also provide 2 baselines for comparison: the aggregated data corresponding to the participants' cohort or organization, as well as all the participants in the study. And all the time series data were visualized using line graphs on the interface. And participants could select any of the summary types and feature types, and they could also hover over the data points to see additional details. And we also included explanatory text alongside each type of visualization describing the data. And we conducted 2 studies with the interface. In our first study, we sent links to participants in 4 out of the 5 cohorts to view their respective visualizations, and we logged and analyzed interactions from 369 participants for a period of 18 days. And in our second study, we conducted a think aloud study with 15 participants in the remaining cohort. The goals of our interaction log study was to characterize the exploratory behaviors of participants as well as define interaction metrics meaningful for personal data contexts. And this study is described in our Eurovis paper. And our second study, the Think Aloud study, we describe our Think Aloud study in this graphics interface paper. And our research questions for the study were: what insights do participants gain from the visualizations? What are the types of contextual information recalled by participants to make sense of their data? And what are the potential usability issues with the interface? Out of the 15 participants in our study, 10 were male and 5 were female. And the chart shows the age distribution of the participants. And 10 out of the 15 participants reported that they use self-tracking wearables and associated apps. And our study was conducted entirely remotely through Zoom. We recorded verbal reports of participant thought processes as they freely explored their data on the interface. We also recorded the screen during the study and gathered interaction logs. We also asked participants to fill out short pre- and post-study questionnaires, We also included questions that were used as measures of data savviness of the participant and the aesthetic appeal of the interface. We began our coding process by segmenting the transcripts, and we used predefined codes from prior work. We applied codes to each segment with the help of screen capture recordings. And here are some results from our analysis. We found that participants spent different amounts of time in exploring their data, and the exploration time ranged from 4.13 to 52.33 minutes, and the number of participant insights ranged from 6 to 40. And to answer our first research question, what insights do participants gain from the visualizations, we corroborated insight types identified in prior work, and we present the complete list of all the insight types in our paper. And to answer our second research question, what are the context types recalled by participants to interpret their data, we identified 5 context types. The first one, so participants recalled various events that occurred during the time frame of the test race study to interpret their data shown on the interface. And here is an example code. And participants also stated their general activities or habits to make sense of the data they were seeing. And participants also recalled various aspects of the test race study, such as the study start and end dates, questionnaire responses, and times when they had issues with their devices. And participants very quickly recognized data points possessing extreme values because they were gathered over the holidays or over the weekends. And participants also recalled seasonal patterns and trends to interpret their data shown in the interface. And to answer our third research question, we found a few usability issues with our interface. We found that the baselines provided on the interface were potentially misleading. So as you can see, the cohort and the all baselines included on the interface, they represent the average values for the participants in the cohort and the study respectively. And as you can see, they appear less variable compared to the participants' data. And participants also found some of the data and textual descriptions to be less clear. We also found that the test race study related information provided on the interface was inadequate, and some of the visual encodings were less effective. And participants also wanted to be able to perform additional interactions with their data on the interface that the interface did not afford. And we also found correlations that suggested that participants who were more data savvy spent more time in exploring the interface and also performed more overview and detailed interactions or summary clicks. And participants who spent more time rated the interface as being relatively less aesthetically appealing. And based on our findings, we present design implications for personal visualization interfaces. Given the potentially misleading baselines, we think that it might be more effective to consider alternative representations of baselines that do not give rise to the issue of dissimilar variability. And our findings also suggest that users may want the option to look at their data in isolation without the baselines. And embedding contextual information within personal visualizations can be helpful to trigger people's memory and enable them to gain richer insights. But this context information may be different for each person and it may not be easily accessible. So self-tracking apps can prompt users to manually log or annotate such information. And based on the context types that participants recalled in our study, we think that it can be useful to denote more generally applicable types of context information within personal visualizations, such as weekends, major holidays, and seasons. And we found that explanatory text and unclear data presented potential barriers to interpretation regardless of participants' exploration time and interest. Hence, it might be effective to minimize the need for reading in general on personal visualization interfaces and to achieve higher explorability through additional interaction mechanisms rather than more textual descriptions. And with this, I end my presentation, and I would like to thank my co-authors, and I thank you all for your time, and I'm happy to take questions. Thank you.
Okay, thank you. Is there any question? Yes, one. Right at the back.
Hello, thank you so much for your presentation. So I wanted to know that I think for your first research question, you have gained some insights which matched with prior literature. So I wanted to know whether this is the same domain as yours and what the insights were, like in summary.
Sure, thanks for that question. So there are a couple of papers by Koei et al. And they looked at personal visualizations too, where people looked at their own data. And they came up with a bunch of insight types. And we actually, like our aim with the first research question was to corroborate these insight types. And we started with the same codes as that were found in the previous papers. And we found that they applied well to our data as well. And some of these codes included, for example, detail, finding comparisons, finding correlations in their data, and so on. And we found around 10 high-level insight types, and there are more like subtypes as well. And the complete list is in our paper.
Thank you. There is a question on Discord. I will read it. Would you consider linking users' work, personal, family calendars to the visualization, if such a calendar is available?
Yes, that would be, I mean, if we had additional data, it would be very useful to include all of that data so that they can, users can find any correlations between different aspects of their personal data too. So that would be great. If we had that data, we would definitely try and include it.
Please.
Thank you, Purna, for that presentation. Interesting work. I have two questions if we have time for those two. The first is, I was just curious, and maybe this is not part of your research question. Did you see any difference between male and female performance or usability with the interface? And the second question was, in terms of designing the interface and then doing research around that, why didn't you just take off-the-shelf interfaces that you talked about and do the same study instead of designing a new interface altogether? Thank you.
Right. Thanks for both of those questions. For the first one, we didn't actually look at any differences between like male and female participants. That one reason is because we had very few participants. We had this was more of a qualitative study. So we had very few participants. We had 5 female and 10 male participants. And for the second question, so we used, although we used data from the Garmin wearable, we had a bunch of other personal data that was collected during the test race study. So the reason we created a new interface was because we wanted to include all of this different data that was not available in other, that other wearable apps usually don't provide. For example, heart rate variability is a new feature that we computed that apps don't usually provide that data. So that was the reason we created an interface that had all of this personal data that came from different sources. So some of it was from the wearable, some of it were from the Bluetooth beacons we used to calculate the number of hours that participants spent at their home and in their workspaces. So because a lot of this data was new, we didn't use any existing interface design, but we created a new one that would include all of this data.
Okay, thank you very much. Thanks, Purna, for answering all the questions. And please join me in thanking her.
Thank you.
Hello everyone, my name is Mahia and I'm happy to present our paper on my master's project. Thank you for being nice, investigating perspectives towards social feedback on Stack Overflow. Online Q&As are a great source for learning where we can find answers to our technical problems quickly. Also, contributors on these platforms can gain recognition by showcasing their skills. For example, on Stack Overflow, a well-known Q&A platform for developers, recruiters look at users' profiles to connect with them. So it's important that these platforms work for everyone, including peoples of different genders. But we know that this is not the case. For example, on Stack Overflow, less than 10% of members are women, which is much less than their actual presence in information technology field. And women earn fewer reputation points on Stack Overflow, which is kind of virtual reward on this site. So how can we promote inclusivity on Q&A platforms? There are many reasons behind this gender gap, but one well-known factor is community culture. Stack Overflow has an unwelcoming environment, which is a barrier for engagement of many users, but especially women and newcomers. Prior work on regulating online community behavior mostly focused on 2 different approaches: automated solutions based on machine learning techniques to detect online toxicity, or involving community moderators. But both of these approaches have some shortcomings and seem to be insufficient. So in this paper, we focused on a preventive approach, and we wanted to see how we can promote and encourage pro-social behavior on Q&A platforms and communities like Stack Overflow. So there is upvote and downvote button on the Stack Overflow on each post, which reflect technical usefulness of the post. However, Stack Overflow misses a social feedback. So we wanted to see how adding a social feedback can affect promoting pro-social behavior, given the important role of feedback in shaping online community behavior. So we designed and proposed a support button as an additional way to react to posts to highlight other important values on the post other than technical usefulness. For example, posters' attitude toward new users, their language, and their tone. And to get and explore users' perception of this idea, we implemented a Q&A prototype. And we made this prototype as much as possible similar to Stack Overflow, and we just added a support button next to each answer and comment, and you can see the number of support a user received here displayed. And to get feedback on different ways that this new feature can be used, we implemented 2 variations of our prototype. Order interface, where answers in a question thread are ordered based on the number of support votes and regular votes they received. And point interface, where each user will earn reputation points based on the support vote they receive. And these 2 variations are corresponding to 2 different ways that upvote and downvote are currently used on Stack Overflow. We conducted interview study. We had between subject design with 2 factors, gender and interface type. We recruited 10 men and 10 women from Stack Overflow members, and we welcomed participants from all gender groups, but unfortunately we could not recruit any non-binary participants. And we assigned participants to 1 interface type randomly, and we balanced the number of men and women per interface type. The interview sessions, the study sessions were online, and they started with an informal introduction, and each participant had 15 minutes to interact with the prototype, and we asked them to read at least 3 questions and their answers, explore users' profiles, and use upvote, downvote, and support vote, basically support button when they feel it's needed. And then there was a short questionnaire regarding their perception of this additional reaction button. And finally, we conducted semi-structured interview with each participant, which was focused on how they have used the support button when they interacted with our prototype and its potential use cases, benefits, or drawbacks in their view. And we also introduced the other interface type that they did not experience to get their comparative reaction. So most of the examples and use cases described by our participants for support button were focused on encouraging newcomers, either by supporting someone who is supportive of newcomers or by supporting posters who apologize for their questions and show lack of confidence. For example, these participants said, I would support a question that was exposing the person's insecurities to show them that it's okay if you don't know this. We all have been there. Some of our participants described negative reactions they have seen or they personally faced when they use Stack Overflow, especially towards simple questions or questions that found to be simple by other peers. But only women said that they're sometimes hesitant to ask their questions because they're afraid of getting similar reactions. So all these women found the support feature as a potential solution to make Stack Overflow a safer space and more receptive to simple questions. For example, this participant said, with the support feature, someone like me would be less scared to write his or her questions there because people would be competing to be more kind and more polite. Participants also said they would like to see a negative version of support button to be able to react to mean behavior or mean comments. There is a flag button on Stack Overflow to report unacceptable behavior, but participants described that something that is mean in their view is not necessarily flag worthy in light of Stack Overflow policies, and they described some situations in the past when they flagged something and it was declined by a moderator. So they felt that by having a negative version of support, they can express themselves and express an opinion when they dislike something without waiting for a moderator to approve it. And regarding our two variations of our prototype, most of our participants like the idea of rewarding reputation point to recipients of support. However, they did not like the idea of ordering the answers based on the support vote and upvote because they rely on the number of upvote to receive the correct answer. To summarize, most of the use cases for the support feature were focused on encouraging newcomers. Women found the support feature as a potential solution to make Stack Overflow a safer space and more welcoming to simple questions. And finally, our participants wanted to see a negative version of support to be able to react to something they don't like and they found mean. So we saw some potential for the support button to make a Stack Overflow a safer space, but its actual impact on gender gap need to be further studied, but we can be optimistic for several reasons. First, we know that Stack Overflow discourages users from saying thank you in the comments, but women dislike this policy and they show their gratitude more often than men on Stack Overflow. By having a social feedback on Q&A platforms, we can enable users to show their appreciation. And also, one of the use cases for the support feature was to encourage users who apologize for their post. And recent analysis of Stack Overflow data showed that women post more apologetic content on Stack Overflow. So by using this feature to encourage users who apologize, we can embrace women and encourage them to engage with the community. Our collected data is incomplete in sense of missing non-binary users' view, which should be addressed in the future, and also our participants had short exposure to this proposed feature while they interacted with a Q&A prototype. So to evaluate the long-term effects and actual behavioral changes, a long-term study with a live community is needed. Thank you for listening, and I would be happy to answer questions.
Thank you, Mahia. If there is, oh yeah, there is a question.
Thank you for your presentation. I was curious about whether any existing research has been done about how people currently use the existing upvote, downvote. Like, do they already use upvotes to indicate support for the way the question was answered? I know the policy says this answer was useful or this answer was not useful, but are you, would you be peeling upvotes away from a question and sort of putting them into a support bucket? Is sort of one question. And the second question is, did you evaluate the sort of extra cognitive load of choosing which button to click on an input basis? So I understand the value of the output, but the input is a separate question.
Thank you. Thanks for the questions. In our study, we didn't describe what they're supposed to use the support button when they interact with the prototype. We wanted to see their view and how they perceive this new reaction button. But almost all participants could easily distinguish between those two. So the participants were recruited were users of Stack Overflow. They were already familiar with the upvote and downvote. And one of the questions we discussed in the interviews were like, how do you usually upvote? Very few of them, they said that they consider other factors other than the technical usefulness of the post. And I just remember like one woman saying that the way the answer is presented, their attitude, is important for them when they upvote something. But other than that, most participants were familiar with Stack Overflow and they perceived upvote to be just related to technical usefulness. And they could, it seems that they could easily distinguish between the two in the interviews, yeah. Thanks for, I don't know if I answered your question.
I just have a quick question. So from my understanding, you can have a username for Stack Overflow that doesn't reveal necessarily your gender. It can be even a number, strange number. What are your thoughts on that? So why don't people choose a username that is not gender-based and get away from all those problems?
So, in the beginning of the presentation, I said that like less than 10% of Stack Overflow members are women. We don't know the exact number because, as you said, like the gender is not specified in Stack Overflow profiles. And there are some studies that try to, detect the user's gender based on the username and the location, if they have the location tag, to see the distribution of different names, gender in different countries, and kind of guess with some kind of confidence the user's gender. But we know that gender swapping is very common on Stack Overflow. So when people feel uncomfortable, having a feminine username, they actually use, a username that specify that they're men. And I think that's the community culture that prevents women to, show their gender. And there is a study that showed, there is a prior work, very well-known work that showed that women tend to be more active when they see another woman, contributing in a question and in a thread. So it's a loop. We don't, reveal our gender, and we see fewer women. So, and I think that's why we should do something about this gender gap. Yeah. I think I forgot your question actually.
No,
Okay,
I was just asking about, why don't people do another username, and you answered it very well. Thank you so much for answer. Okay, I guess, is there any other question? And if not, please join me. Oh, there is one, sorry. Michael.
Hi. So I had more of a comment. I've been married more than 20 years. And I think as I've gotten older, I've become more observant of differences between my wife and me. So my wife is very high in agreeability, and she'll often apologize to me when it's not her fault, right? Sometimes I'm with her and I'll say to her, I think you said sorry 10 times to me today so far. And we took a test once online. It was a test for narcissism. I scored kind of higher than average, and she scored almost a 0 on this test. So I think it's really interesting to become more aware of these differences. Of course, every individual is different, and there's overlap in the distributions of things like agreeability between men and women. But I think it's a good thing if young people, young students are more aware of these things, and if we're more sensitive to these issues, because they do have a big impact on how welcome people feel, right? So thanks for doing this work.
Yeah. Thank you. I think, defining gender is tough. It's like, I think the official definition on WHO is gender is social construct. So I think the definition will evolve. We don't have same understanding from gender now, like from in the past, and comparing with in the future. There are some correlations between like personality traits and gender. But I think these kind of work, regardless of gender, they can benefit some people that like have some specific personality traits, and even we have total different definition and understanding of gender in future. Still, considering different aspects can obviously have benefits, like to have inclusive communities. Yeah, thank you. Thanks for your comments.
Thank you very much, Mahia. It was great work and great presentation.
Hello, everyone. My name is Ahud Al-Harbi. Today, I am going to talk about our research, which is the impact of autocorrection failures on user frustration. Text entry on mobile device has advanced much, but there are still a downside, as you see in this autocorrect failed. In the first example, the autocorrection corrected a proper name, Hunan beef, to human beef. While in the second example, it's a classic one key off error. It's autocorrected deer to dead. So why we are studying frustration? A frustrating interaction with a computing device can cause users to feel negative emotion toward the system and to potentially abandon using some functionality. Then they might not be aware how much the system has improved and still keeps improving due to continuous usage or system updates. Also, there are no text entry studies that investigate the effect of failing autocorrection on user frustration and emotions. Text entry is a selection of symbols from a keyboard layout, typically arranged in a grid. The most well-known example is the QWERTY layout, named after the first 6 characters on the top row of letter keys, as you see in the 2 images. Key selection techniques ranges from a direct pointing using a single or multiple fingers to indirect pointing from a distance or through a control device. Due to the growth of text-based social media, such as Facebook posts, tweet, group messages, texting is the main way of communication these days. Many users rely on autocorrect feature to accelerate text input. However, being fast and accurate can be challenging on touchscreen due to compounding issues such as misspelling, wrong touch location, or a missing character or space. Our work aims to highlight the potential side effects of automatic or smart features, such as autocorrection. We formulated the following research question. What is the effect of failing autocorrection on the user's level of frustration and perceived workload? We used a mobile application for data collection. We exposed participants to 4 conditions: optimal, failure 10%, or failure 20% of the time, also no autocorrection condition. The optimal condition always produces perfect autocorrections, which closely resemble an oracle. We force frustrating events through autocorrection failures and then ask participants to subjectively report on their experience during the study. For autocorrection that fails 10 or 20% of the time, the system generated a believable, close enough result. We ran the study with a between-subject design with 4 conditions. Before starting this study, participants were asked to fill a background questionnaire and an English proficiency test. Participants then typed 30 phrases randomly selected from a random phrase set. We repeatedly assessed task workload and frustration through self-report questions. Also, we asked participants to use the think aloud method and report their emotions and what they felt during the study. Finally, we conducted interviews. So the result? In terms of word per minute, we observed a significant effect on text entry speed with medium effect size, with optimal being the fastest option, as you see in the figure. Optimal and 10% autocorrection required significantly less verification time, which is the time to verify the phrase before submitting it. We observe a significant effect on frustration across condition with a large effect size. Optimal stood out by being the least frustrating, as you see in the figure. There was also significant effect on mental demand across conditions with a large effect size. No autocorrection was significantly more mentally demanding than condition with no or occasional failures. We also observed a significant effect on physical demand with a large effect size. No autocorrection and 20% autocorrection fails were the most physically demanding, as you see in the figure. So our discussion. Overall, lowering the percentage of autocorrection failures will reduce frustration. We observed that using autocorrection significantly increased typing speed. However, we did not find a significant difference between the 10% and 20% failing options in terms of typing speed. With autocorrection, we noticed that the participant speed tends to keep increasing with practice, while without autocorrection, it initially increased but then flattened out. No autocorrection and autocorrection with 20% failures stood out as the most frustrating interaction or conditions. There is also a chance that the frustration stems from the participant frustration with themselves when they make errors. This brings the question of how small the acceptable percentage of autocorrection failures should be. Despite occasional failures, participants felt that they needed less mental demand with autocorrection regardless of its accuracy. In the post-session interview, we asked participants about this. Most of them said, in one way or another, that they accepted that autocorrection fails occasionally. Participants spend the least time verifying the phrases in both the optimal and autocorrection with 10% failing conditions. Participants indicated that autocorrection is overall a useful feature when used sensibly. However, they also felt that it can change the meaning of the sentence if they do not pay sufficient attention. With the advance in personalization, system can expose sensitive data at an appropriate time. Some participants mentioned that autocorrection weirded them out and that they were concerned about the privacy issues. Mistakes that are the hardest to correct are typically the ones happening at the beginning of the sentence. The majority of participants mentioned that some mistakes occur because they use multiple languages on their keyboard. Participants emphasized that they would like to see keyboard with built-in grammar checker. Some participants wished to have a slightly more hidden and less distracting visual feedback, while others wanted highlighting and more obvious feedback. The participants made several interesting design recommendations. Some indicated that they would prefer if there were a single step button to quickly toggle autocorrection, or if there were a drop-down menu for autocorrected words, like on a desktop. Others indicated that they want to see a confidence score on the side of the screen, or an easy method to add or delete words from dictionary. Another recommendation was to have an option for autocorrection based on location, because people communicate differently in different locations. A limitation of the study is that our autocorrection implementation might have produced slightly different outcomes relative to system-generated predictions. We use our own implementation because we wanted to tightly control the percentage of autocorrect failures and to explore the best case scenario with a perfect autocorrection condition. Thank you for listening. If you have any questions, feel free to ask me or email me. This is my email. Thank you.
Hi, Uhud. Thank you for joining us.
Hi.
So I see there are some typing happening. Oh, okay. There is first question we have on Discord. I think you mentioned that the optimal autocorrect was always correct, but how do you actually do that?
Yeah, thank you for the question. Actually, what we did is somehow we wired the system to usually or always produce a perfect condition, because we have a transcribe task. So we know the text, what's the text supposed to be. So if it's like 2 letters or 3 letters far off what's the supposed word, so we produce exactly the same word. But if they are far off, we keep the mistake, so we don't autocorrect it.
Thank you. I have one question. How did you measure frustration and mental and physical demand?
We use NASA TLX, so it's a prompt that happens overall 7 times, like at the beginning of the session 1, at the end of the session 1, and 5 during the typing task.
Thank you.
Hi, Oud. I'm going to ask you a question. And I am the holder of the microphone, so I guess I get to do that. So one of the things that also tends to help with the autocorrection is the prediction part, where you've got prediction words that are appearing that you can choose rather than typing your entire word. Did anybody mention the prediction? It kind of a little bit was vague with respect to the recommendations with drop-down menus and things like that. I'm kind of thinking that might have been related to prediction.
Yeah. Actually, I have done like other research about the prediction, and I have found that it slowed down text entry speed. So even though that I did like a crowdsourced study, it's a different study, and I found that it slowed down actually typing speed. So it's faster to type the word because of the cognitive overload. For this study, we focused only on autocorrection because we found autocorrection actually increases speed, or in other study did not have an effect. So we said, okay, let's focus on that. Thank you for the question.
Thank you for your presentation. So I just wanted to ask, like, there are several other techniques other than typing. We can glide, swipe. So did you use those techniques? And I had another question. Sorry, I have too many questions, I guess. So sometimes we use the next word predictions, like we type one word and select the next one. It significantly increases our typing speed. So did you take that into consideration?
For this study, we focused only on autocorrection, but I have studied the word prediction in different studies. This is for the second question. For the first question, what we did is we asked participants to enter words and on their own keyboard. So some of the participants used like a type keyboard, some of them has like a swipe keyboard. However, I believe only 2 had like a swipe keyboard. So they are using their own system, using their own keyboard, what they are used to.
So the words you gave were random words? They were typed, the phrases were random, right?
The phrases are a phrase set. So it's not random, like we display phrases and we ask them to type it on their keyboard. So it's actually with application. They load this page and type on their keyboard.
Okay, thank you.
You're welcome.
Thank you very much, Ahud. Please join me in thanking her. I guess we can end the session now.
Okay, so we just end the session. So we will resume at 2, right? So we will have just to give you like some kind of a heads up, we will have a keynote speaker like Sydney that will do a presentation. He will be not here because he have COVID, unfortunately, so it will be a remote presentation, but on live, like you will use Zoom. And then we will have a paper session about sketching, detecting user abilities, and we will finish today with the Early Career Researcher Award by Magnolis, and we will have then the dinner, okay? So for the dinner, the place is 10 minutes away. We will give you some further instruction on Discord and also during the end of the session so that you don't get lost and you end up to the good restaurant, okay? So enjoy and see you at 2.
Thank you.